Hi everyone, so in this video I'm just going to go over some examples that are similar to the problems in the 2.04 TGA. So the first problem wants you to solve an absolute value equation very similar to this. So remember what we do whenever this is positive, we just break this into two cases, right? So we have 2x minus 4 is equal to 12, and we also have 2x minus 4 is equal to negative 12. So now we just need to solve these two equations in order to find the value of x. So on this left side, I'm going to go ahead and add 4 to both sides. So when I add 4 to both sides, I'm going to end up with 2x equals 16. So now to solve for x, I just need to go ahead and divide everything by 2. So when I divide everything by 2, I get x equals 8. So now let's go over here and we'll actually use the same steps to solve this equation. So I'm going to add 4 to both sides. And then after I add 4, I end up with 2x equals negative 12 plus 4, which is negative 8. So now I'm going to divide both sides by 2, and when I divide both sides by 2, I get x equals negative 4. So remember, whenever we're solving absolute value equations, we do have the possibility that we'll end up with an extraneous solution. So we always want to go back and plug in our values for x and make sure that our solutions work. So if I plug in x equals 8, so we have absolute value of 2 times 8 minus 4, and we're checking if that equals 12. So that's the absolute value of 16 minus 4, and we're checking if that equals 12, so that's the absolute value of 12 equals 12, which is in fact true. So now let's try x equals negative 4. So we have x equals negative 4, and we plug in and we get 2 times negative 4 minus 4 equals 12. So 2 times negative 4 is going to be negative 8. Negative 8 minus 4, so we're taking the absolute value of that, and that's equal to 12. So we have the absolute value of negative 12 equals 12, which is in fact true. So actually both of these solutions work out, so they're going to both be solutions to this equation. So now let's go ahead and solve this equation. We have the absolute value of 3x plus 15 equals 6x. So once again, we're going to do the two cases. So we're going to do 3x plus 15 equals 6x, and we're going to do 3x plus 15 equals negative 6x. And so now we just need to solve these equations for x. So remember, whenever we have a variable on both sides, we're going to first work on moving the variables all to one side of the equation. So I actually think it's easier here because this is a positive 3x. I think it's easier to go ahead and subtract 3x from both sides so we can get all our x's on the right side. So we have 15 equals 6x minus 3x, which is 3x. And now we're going to go ahead and divide both sides by 3. And so we end up with 5 equals x, right? Because 3 and 3 will cancel. So now over here, we're going to go ahead and subtract 3x from both sides. So when we do that, we get 15 equals negative 9x. And then we're going to divide both sides by negative 9 in order to get x by itself. So when we do that, we get negative 15 over 9 equals x. And remember, we want to reduce these fractions whenever possible. So when we have negative 15 over 9, we're going to divide both of these by 3. So that's going to give us negative 5 in the numerator and then 3 in the denominator. So that means that negative 5 over 3 equals x. So let's go ahead and plug these in and make sure we don't have any extraneous solutions. So when I plug in x equals 5, I'm going to get the absolute value of 3 times 5 plus 15, and we're checking if that equals 6 times 5. So that's the absolute value of 15 plus 15, and that's equal to 6 times 5, which is 30. So that tells me the absolute value of 30 is equal to 30, which does in fact work out. Now over here, let's try this. We have x equals negative 5/3, so we have the absolute value of 3 times negative 5 over 3 plus 15 equals 6 times negative 5 over 3. So we have the absolute value of negative 5 over 3 times 3, so there the 3's just cancel, so we have negative 5 plus 15, and that's equal to 6 times negative 5 is negative 30. Negative 30 divided by 3 is negative 10. So this actually tells me that the absolute value of 10 is equal to negative 10, which is not true. So that means that this is an extraneous solution, right? So we're just going to cross that out, and we're not going to include that in our final answer. So the only solution is going to be 5 equals x. So now let's try solving this equation. And actually what we're going to do is we're going to solve this one by graphing. So what I'm going to do here is I'm going to take this and make that y in my Desmos. And then I'm going to make this another y, right? So I'm just going to go to Desmos and type in y equals the absolute value of 2x plus 7 and y equals 5. So you can see here, I've typed both of these equations into Desmos, and you can see that we have two intersection points. And remember, the x values of those intersection points are going to tell me the solutions to this equation. So the intersection points we found were negative 6, 5, and negative 1, 5. So those x coordinates, okay, so that x equals negative 6 and that x equals negative 1 are going to both be solutions to this equation, right? Remember, you can always check by plugging in. So we have 2 times negative 6 plus 7, and then we're checking if the absolute value of that is equal to 5. So we have the absolute value of negative 12 plus 7 is equal to 5, which tells us the absolute value of negative 5 equals 5, which is in fact true. If we tried negative 1, we have the absolute value of 2 times negative 1 plus 7, and we're checking if that equals 5. So we have the absolute value of negative 2 plus 7, and we're checking if that equals 5. So the absolute value of 5 is equal to 5, which is also true. So since both of these are true, we can say that the intersection points tell us the solution, right? So you can write that out in a few sentences, but basically what I'm looking for is that intersection points give us the solution. So that's how we can figure it out by graphing. Okay, so that's all the examples for this TGA.